So this is the second part of 2.5. We're going to learn Bernoulli's equation. So this dE in this form, where n, the power here n is real, is called Bernoulli's equation. So if we have n equals 0 or n equals 1, well then all we have is a linear equation. We can use the methods we've already learned to solve it. So we're looking at when n is greater than 1. So our process is that we're going to substitute u equals y to the power of 1 minus n in order to reduce the differential equation form to a linear. Let's try it. If we're going to substitute u equals to y to the 1 minus n, well, we're going to need to take the derivative because we're going to need dy dx. So du. So since we're going to be substituting into here, we will need to find dy dx. So let's take the derivative power rule and chain rule. Now let's solve for dy dx. And let's go ahead and plug it into our equation. Let's write our equation first. So dy dx is equal to this. So let's replace this. So I'm going to actually divide by y to the n. By the way, this is going to be, even though we're doing this in general, this is going to be the process that we are going to follow every single time we use Bernoulli's. And we can see we have u. We have u in our equation now. And now we've accomplished our goal. This is linear in u now. And then we'll be able to solve it using one of the other techniques from another section. Let's try an example. So we have here n equals 3. So we're going to use the substitution u equals y to the 1 minus 3. So du. So now we want to plug in dy dx, so we have to solve for dy dx. Substitute it into the equation. So we're going to divide by y to the third like we did above. So it looks like we have our u. And now we are linear in u. Just need to get rid of our negative 1/2 in the front. Get it in standard form. And I'm looking at this. If I multiply dx, is it separable? I don't think it is. So we're going to use integrating factor, and it could be a good review for that. It's in the form. I cleared my minus 1/2, so it's in the form. The mu is my integrating factor. And it looks like this is my p of x is equal to minus 2. So that's e. So now I'm going to multiply through by my integrating factor. This can be written as a product. And it's going to be, so I look at this, and on the right side, and let's check our product rule here. There's our u's. So that is e to the minus 2x. And it looks like they check out. Now we can integrate both sides. Dx, the The integral and the derivative cancel out. There's my plus c. Let's go ahead and solve for u. And let's back substitute. U was y to the minus 2 up here. And if we want to solve for y, we could do that. Take the reciprocal of both sides, since that is 1 over y squared. Looks prettier if that positive one is in the front. And square root, square root. So this is our general solution and our particular solution. Okay, so we want to solve this. There's actually more than one way to solve this, but we're going to use Bernoulli since we just learned it. So we have to get it in the right form. So remember, in case you've forgotten already, the form we need a linear in y right here, and put everything else to the other side. So this is the term we want to bring to the left. And I'll just rewrite that y like so. So now we can see that it's in the right form and that our n is minus 1. So u is y to the 1 minus minus 1, which is y squared. So u du dx dy dx. I'm going to solve for dy dx though. So we have these two. Dy dx we replace. So we're going to solve for dy dx. Looks like dy dx is just 1 over 2y du dx. So this is the same thing. It's 1/2 y to the minus 1. Just so we can see, we're going to divide by y to the minus 1 or multiply through by y. It's the same thing. It's just the same process. And that's what you need to do with Bernoulli, is just keep practicing these until you see the similarity in every single problem. And here, that's our u. And looks like we might have to use integrating factor. So multiply through my p of x for integrating factor. So my integrating factor is mu. That minus e to the minus 2 comes out. Natural log of x. You have to use the power rule first before those cancel. And this becomes x to the minus 2. So we are going to multiply through by x to the minus 2. Rewrite this left side as a product times u. And let's check that product. So it's going to be x to the minus 2 du dx plus minus 2x to the minus 3 times u. So yeah, that does put us x to the minus 3, or x to the third on the bottom. So yeah, it works. So now we integrate in terms of x. These just cancel. Plus d. Let's clear our fraction. U. And remember, our u is still y squared. And we have our general solution.